In question 1, so we have to find the dimensions of A, linear momentum, B, frequency, and C is pressure. So first of all, linear momentum. Okay, first of all एक फॉर्मूला देख लेते हैं जिसमें लीनियर मोमेंटम का फॉर्मूला इज linear momentum is denoted by letter P and it is equals to m into v, where m is the mass, v is the velocity. So we can say the dimension of linear momentum will be equals to this. So we can write it something like this: dimension of mass into dimension of velocity. So dimension of mass is m raised to power 1 and the dimension of velocity will be L raised to power 1 t raised to power minus 1. So from here we can say m raised to power 1 L raised to power 1 t raised to power minus 1. So this is the dimension of linear momentum. In second part we have to find the frequency dimension. So frequency, frequency basically it is denoted with the letter nu, and frequency is equals to 1 by t, where t is the time. So from here we can say the dimension of frequency will be time raised to power minus 1. And in the third part we have to find the dimension of pressure. So we know that pressure is equals to force upon area. So the dimension, say I denote it with letter P, is equals to dimension of force upon dimension of area, and dimension of force is m raised to power 1 L raised to power 1 t raised to power minus 2, and the dimension of area is L raised to power 2. So from here we can say the dimension of pressure is m raised to power 1 L raised to power minus 1 t raised to power minus 2. Okay, इसका जो एक्सपोनेंट है ऊपर जाकर माइनस हो जाएगा, -1 -2 will be -1. In question number 2, find the dimension of angular velocity, angular acceleration, torque and moment of inertia. And some of the quantity equations involving these quantities is also given, and here we have the equations. So in question second, the first part is your angular velocity. So we have to find the dimension of angular velocity. So here we have given the formula: omega is equals to theta 2 minus theta 1 upon t2 minus t1. This theta basically is your angular displacement and it is your dimensionless quantity. So dimension of omega will be dimension of this angular displacement upon dimension of, this is the difference of time, so it will have the dimension of time. So we can write it as, it has no dimension, so we can write it as 1, and it is time, so t raised to power 1. So the dimension of angular velocity will be t raised to power minus 1. And the second is your angular acceleration, and the formula is given to you. So dimension of angular acceleration को निकालना है, and the formula is given: difference of angular velocity divided by the difference of time. So the dimension of angular acceleration will be dimension of angular velocity divided by dimension of time. So angular velocity की dimension अभी हमने निकाली है, that is t raised to power minus 1, and the dimension of time is t. So from here we can say it is t raised to power minus 2. So the dimension of angular acceleration is t raised to power minus 2. Now the C part is we have to find the dimension of torque, and the formula is also given: F dot R, F into R, not dot, it is F into R. So in C part, we have to find the dimension of torque, and torque is given as F into R. So dimension of torque will be dimension of force into dimension of R. R is a distance. Force will be m raised to power 1, L raised to power 1, T raised to power minus 2, and the dimension of distance, that is L raised to power 1. And from here we can say m raised to power 1, L raised to power 2, T raised to power minus 2. So this is the dimension of torque. In the fourth part, we have to calculate the dimension of moment of inertia, and the formula is also given to us, that is mr square. Basically it is the formula for the moment of inertia of a ring about the axis passing through its center and perpendicular to the plane of the ring. So here we have mr square. So dimension of moment of inertia will be dimension of mass into dimension of r square. Mass m raised to power 1, and r square is length, L raised to power 2. So it will be m raised to power 1, L raised to power 2. Okay. In question number 3, we have to find the dimension of electric field, magnetic field, and magnetic permeability, mu naught, and the formulas are also given to us, where F is equals to QE, F is equals to QVB, and B is equals to mu naught I upon 2 pi A, where I is the current. So let us find question number 3. First part, that is electric field की dimension निकालनी. So the formula for electric field is also given, that is F is equals to Q times E. So the dimension of force will be product of the dimension of charge and electric field, and from here we can say dimension of electric field will be dimension of force upon dimension of charge. And dimension of force is m raised to power 1, L raised to power 1, T raised to power minus 2, and dimension of charge is current की dimension into time. So from here we can say m raised to power 1, L raised to power 1, T raised to power minus 3, I raised to power minus 1. So this is the dimension of electric field. In B part, we have to find the dimension of magnetic field. So the formula is also given to us, that is F is equals to Q V B. So from here we can say the dimension of magnetic field will be force upon charge की dimension upon velocity की dimension. So it will be m raised to power 1, L raised to power 1, T raised to power minus 2, and the charge is I raised to power 1, T raised to power 1, and V is your velocity, that is L raised to power 1, T raised to power minus 1. So if we club these quantities, so we have m raised to power 1, this L will cancel out with this, and this will cancel out with this. So we have T raised to power minus 2, I raised to power 1. So this is the dimension of magnetic field. Now in the third, we have to find, in your C part, dimension of magnetic permeability, and we can use the formula of B is equals to mu naught I upon 2 pi A. So from here, dimension of mu naught will be dimension of 2 pi into dimension of B into dimension of A upon dimension of current. So it is dimensionless quantity, तो मैं इसको 1 लिख देता हूँ. B के भी dimension में निकाली है. So B is this, m raised to power 1, T raised to power minus 2, I raised to power 1, and this A is distance, so it will be L raised to power 1, and denominator we have I raised to power 1. So this I will cancel out with this, so we left with m raised to power 1, L raised to power 1, T raised to power minus 2. So this is the dimension of magnetic permeability. In question number 4, Find the dimension of electric dipole moment P and the magnetic dipole moment capital M, and the formula is also given. P is equals to Q times D and magnetic dipole moment is equals to I, where I is the current, A is the area. Okay, let us find first your dimension of electric dipole moment, and P is equals to Q into D, where Q is the charge, D is the distance. So dimension of P will be dimension of Q into dimension of D. So dimension Q is I raised to power 1 T raised to 1, and dimension of D will be L raised to power 1. So if you put it in some order, it will be L raised to power 1, T raised to power 1, I raised to power 1. And in B part, we have to find the dimension of magnetic dipole moment, and the formula is given to us as I into A. So the dimension of magnetic dipole moment will be dimension of I into dimension of A. It will be I raised to power 1, and dimension of A will be L raised to power 2. So this is the answer of question number 4. In question 3, there is a correction. Here the I is in the denominator, so here we have I raised to power minus 1, and if here is I raised to power minus 1, here I raised to power 1, so we will get I raised to power minus 2. Okay, so there is a minor correction. In question number 5, find the dimension of Planck's constant h from the equation E equals to h nu, where E is the energy, nu is the frequency. So in question number 5, we have given E is equals to h nu, and we have to find the dimension of h. So the dimension of h will be dimension of E divided by dimension of frequency, and the dimension of E is m raised to power 1, L raised to power 2, T raised to power minus 2, and the dimension of frequency is T raised to power minus 1. So from here we can say the dimension of h will be m raised to power 1, L raised to power 2, T raised to power minus 1. So this is the answer of question number 5. If you have any doubt regarding any problem, you can ask in the comment section. Okay, thank you.